Right now, we continue with example 3 under bacterial colony. The initial number of a bacterial colony is 100. After 5 hours, the number of bacteria become quadruple. Assuming that the number of bacteria increase at a rate proportional to the number of the bacteria at time t, find the number of bacteria after 1 day. Right? First, from the word initial, we can write t equals to 0. Okay? And then 100 means we can write p equals to 100. T stands for time and p stands for population. Right? First, we write t and we write p. Okay? And then after 5 hours, so we can write t equals to 5 hours. And then the number of bacteria become quadruple. So from the word quadruple, so we can write p equals to 400. Okay? Because the word used is quadruple. Alright? And then find the number of bacteria. That means we need to find p. So p equals to question mark. Okay? And then after 1 day. Okay? So we can write t equals to 24 hours because 1 day equivalent to 24 hours. So we need to write t and p. Okay? We extract from the original question, we extract and then we write in terms of t and p. Right? And then from dp over d time equals to kp. Okay? We separating variables t and p, okay, we can move over dt to right hand side, so it become multiplication. And we can move p to the left hand side, so it become 1 over p and then dp equals to k and then times dt, right? And then integrating both sides, okay? From 1 over p dp equals to k dt, we just put integration sign for both sides, alright? Then we can integrate 1 over p dp, okay, equals to ln p plus c, okay? And then integrate constant k dt equals to kt plus c. We just put plus c on one side only, okay? So, integration of 1 over p dp, we can refer from integration of 1 over x dx, which is equals to ln x plus c. So, when the variable used is p, okay, dp, so the answer should be ln p, alright? And then, to integrate the right hand side, we can refer from, let's say we integrate 2 dx, 2 is constant. And k here also constant, okay? So when we integrate 2 dx, it becomes 2x plus c, okay? So now we have integration of k dt. K is constant. So now we integrate with respect to t, so it becomes k and then variable t and then plus c, alright? After that, we need to write p as a subject because p is a population, okay? So to write p as a subject, we need to move ln to right hand side, okay? And when we move ln to right hand side, we get p as a subject, and then e, okay, when we move ln to right hand side, we get e, and then the power of kt plus c, right? And then from the right hand side here, okay, we can use the properties of indices to separate. So we can write e the power of kt times e the power of c. Okay. This comes from the properties of indices a the power of m times a the power of n. It equals to a the power of m plus n. We plus the exponent. Okay. So now we have kt plus c, so we separate, so it becomes multiplication, okay, from here. Alright, And then we can write P equals to C EKT. Okay, E the power of C here actually equals to constant because E is an Euler's number, which is 2.718 something, which is also constant. So constant, the power of constant equals to constant. So for E the power of C, we can write C and then E the power of KT. Right? And after this, when we need to solve bacterial colony or population growth or radioactive decay, we can use this equation. But before that, we need to show from dP over dt equals to Kp, we need to show until we get this formula. Because when we show how to get to P equals to C EKT, means we show that we use the application of differential equation. Okay, I mean the first order differential equation, right? So after we get P equals to C e the power of KT, we can write equation 1. Okay, we can name it as equation 1. Alright. Alright, from the previous slide, P equals to C e the power of KT equation 1. Okay, then we can substitute the first information to find the value of C here. Okay, and we can substitute the second information to find the value of K here. Alright. Okay, so to find C, okay, substitute T equals to 0 and P equals to 100 into equation 1. Alright. So from P equals to EC the power of KT, okay, we replace P equals to 100, okay, and then we replace T equals to 0 here, so we get E the power of 0, and E the power of 0 is 1, so we get C equals to 100, okay. After that, we substitute C equals to 100 into equation 1 here, okay, so we get P equals to 100 E the power of KT, right? Then we can name as equation 2, right? And then to find K, okay, we substitute T equals to 5 hours and P equals to 400 into the latest equation into equation 2, alright? So from equation 2, P equals to 100 E the power of KT, okay, we replace T equals to 5 hours and we replace P equals to 400, okay, so we get E the power of 5K, and then we can move 100 to left hand side, so it becomes 400 over 100, okay, and then we get E the power of 5K equals to 4, okay, we get back 4 here because from the word quadruple, alright, and then we need to find K, okay, so to find K, we need to move E to right hand side. Okay, so when we move E to right hand side, okay, it becomes ln. Okay, so we will get 5K equals to ln 4. Alright, so we get ln here. Then we can solve K equals to 0.06532 using calculator. Alright, and after that, we substitute the value of K into the latest equation, which is equation 2. We substitute here. Okay, so we get P equals to 100, okay, from equation 2, E, and then K, we replace by, K here, we replace by 0.06532, okay, and then T, okay. This is the population of bacteria at any time T, okay, and after that we can name it as equation 3, alright. Alright, from the previous slide we get P equals to 100 E the power of 0.06532 T. Okay, and then we use T equals to 24 hours and we substitute into 3 because the question is find the number of bacteria after 1 day. Okay, so substitute T equals to 24 hours means 1 day into equation 3. Okay, from equation 3 we have P equals to 100 e the power of 0.06532 T. Okay, so now we replace T by 24. Okay, and then using calculator we get the answer P equals to 479.6. Okay, but for bacterial colony and population it is impossible to get decimal value. Okay, because this is only approximation. Okay, so when we find population or bacteria, okay, we should write in terms of whole number. So we can write that there are 480 bacteria after 1 day. Alright, so this is the final answer. Okay, and before that, how to calculate this using symbol lab. Okay, so we just press 100 and then E the power of 0.06532 and then times 24. Then after we press enter, so we get this answer. Or using calculator, okay, from your calculator, okay, to find E the power of something here, okay, first we need to press shift button, okay, and then ln, okay, and then open bracket, okay, and then we press 0.06532 and then times 24 here, so times, okay, and then 24, and then we close bracket, okay, and after that we press equal. So after we press equal, we will get the value for E the power of 0.6532 times 24. Okay, and then we times 100. Alright, so we will get the answer 4.79.6. Right? Coming up next, radioactive decay. Thank you for watching. Stay tuned. Bye. Assalamualaikum.